We've all been there, right? You run a standard system update on Kali, feeling good about being up to date, and then your most trusted tool, msfconsole, just falls flat on its face. It's super frustrating. But here's the good news. It's almost never a total disaster. It's more like a solvable mystery. And in this explainer, we are going to crack the case together.
And you've got to love this quote from the source material because it hits home. It perfectly nails that slightly ridiculous feeling when a mission-critical tool suddenly acts like it's in a comedy routine. It really sets the tone for what we're about to do. Take a real, no-nonsense look at why this happens and, more importantly, how to fix it for good.
Okay, so let's set the scene properly. You've just run apt update and upgrade. You pop open a terminal, type msfconsole, hit enter, and bam, a wall of angry red text. Your number one tool is down for the count. This is our crime scene, and our investigation starts now.
Now, I know what you're thinking. Oh no, Metasploit is totally broken. I have to reinstall everything. But hold on, that's almost never the real issue. The real culprit is usually a three-way argument between Ruby, Bundler, and your shell's path. Think of them as a band that's suddenly out of tune with each other.
Before we go typing a single command to try and fix this, we need to do what any good detective does. Gather some evidence. We need to look closely at that error message. Just blindly trying solutions is the fastest way to turn a small problem into a really big one. So here's our game plan. First, run msfconsole again, but this time with a V for verbose. This gives us the full story, not just the headline. Then, grab the first 25 lines of that output. This is what the source calls your symptom signature, and trust me, it holds all the clues we need to figure out exactly what went wrong. And once you have that error message, this little chart is basically your decoder ring. It helps us classify the problem. If you see the words bundler and Ruby hanging out together in the error, it's a huge sign that your path is mixed up. If it's complaining it could not find gem, well, that's a packaging problem. And if you get some really cryptic stuff like open SSL symbol, that points to a mismatch in the underlying system libraries. This tells us exactly where to focus our efforts. All right, we've got our clues. Now it's time to bring in the usual suspects for a little chat. Ruby and Bundler. I can tell you right now, the problem almost always comes down to how these two are interacting. Or, more accurately, failing to interact on your system. And this brings us to the absolute core of the issue, something called path precedence. Just think of your path as a list of addresses. When you type msfconsole, your shell looks through that list, in order, for something that matches. The very first one it finds, it uses. First match wins. So you might have the correct system version of Ruby installed, but if an older user-installed version appears earlier in your path, that's the one your shell is going to grab, even if it's the completely wrong one for Metasploit. So how do we find out what's going on? We interrogate the system. We ask it some very simple but very revealing questions. We run which msfconsole to see the exact file it's trying to execute. We ask it which Ruby and which bundler it's using. And, a really big one, have you ever played around with a Ruby manager like RBN or RVM? The answers here will almost always shine a big spotlight on the problem. And this right here, this gets to the heart of it all. Most of the time, when we say msfconsole broke, what we really mean is I accidentally mixed two different ecosystems. You have the official, carefully managed world of Kali's system packages, and then you might have this separate, user-installed world of gems. When those two worlds collide, things break. Okay, the investigation is over. We've gathered the clues, we've identified the culprit. It's time for the verdict. And the good news is we have enough evidence to confidently apply a fix. The source material gives us two really clear and effective paths to get you back up and running. So you've got two main choices here. Path A is what we're calling snapback. This is about forcing your system to get back in line with Kali's official packages. For most of us, this is the safest, cleanest, and best option. Then there's Path B, pin and rollback. This is more like performing surgery. You freeze specific packages out of version you know works. This is a strategic move for when you absolutely, positively cannot have your tools change on you, maybe in the middle of a big project. Let's walk through Path A, the snapback. First, the basics. Update your package lists and fix any obviously broken dependencies. But step 3 is the magic bullet. You're telling the package manager to reinstall Metasploit, Ruby, and Bundler from the official source. This just paves over any conflicting versions. And that last step is crucial. You verify it works in a totally clean environment. That nv-i command. Make sure your old broken path from your current session isn't tricking you into thinking it's still broken when it's actually fixed. Now, path B is a bit more advanced. You're basically a system archaeologist. First, you dig into the DPK logs to see exactly what packages were upgraded recently. If you find the one that caused the problem, you can try to roll it back. But here's the most important part. You pin that package with apt-mark hold. This tells your system, hey, whatever you do not touch this package during future updates. You're trading bleeding edge for rock-solid stability. And please, listen to this next part. It is so important. If you go with Path B and pin a package, you absolutely must leave yourself a note explaining what you did and why. Because 6 months from now, you'll have forgotten all about it. You'll be wondering why your system won't update properly, and you'll realize you've sabotaged your future self. A simple text file can save you hours of headache down the road. Look, getting your system fixed is great. But what's even better? Making sure this never, ever happens again. So let's talk about future-proofing. Let's turn this reactive fix into a proactive strategy for a stable system. This is probably the best habit you can possibly build. The source calls it a post-update smoke test. It's so simple. Right after you run an upgrade, just take 60 seconds, that's it, and launch your most important tools. Run msfconsole-v, run nmap-version. If something broke, you'll know immediately, while the update is still fresh in your mind. This turns a night-ruining disaster into a minor 2-minute annoyance. And this right here is your golden ticket. This is probably the most valuable thing you can do for yourself. Create a simple text file, call it your break glass note, and right now, while everything is working perfectly, record these 6 simple facts. This is a snapshot of your healthy system. It's your map to get back home if you ever get lost in the woods of a broken update again. It makes future troubleshooting incredibly fast. So the whole point here is to take action. Don't just watch this and think, yeah, that's a good idea. Actually do it. Open a terminal right now, run those which and v commands from before, and create that note. This 2-minute task is the difference between future panic and future confidence. So I'll just leave you with this question. What will your break glass note say?